My name is Rick Astley. I make occasional videos on this channel about Jaguar XK electrical issues. I'm not one of those "what's up guys, make sure you subscribe, ring the bell and give me a thumbs up" type of YouTubers. My only purpose is to document, mostly for posterity I guess, things I learn about XK electricals that I couldn't find elsewhere on the web. In many ways I hope you haven't found this video as a result of you needing to search for it. That's because it describes a serious problem, and one that at one point I truly thought may result in my beloved XK8 having taken its last journey before the wrecking yard. It concerned a time when my perfectly running XK8 suddenly became a hunk of useless metal, refusing to show any signs of life. I have to apologise for the fact that for various reasons it's taken over 2 years since this happened and my getting around to posting it, and for the fact that my primary goal was to get the car fixed and not take many photographs. If you'll bear with me, the background to this is relevant. I worked for nearly 30 years as an electrical engineer in the auto industry, which, as you probably know, in the US is centred around Detroit or Motown, including its suburbs and the city of Windsor across the river in Ontario, Canada. Although in different countries, Windsor and Detroit share a common economy and culture to the extent that, at least up to the event of COVID, people move freely and frequently to and fro across the border for dinner with friends, sports events, shows and the like. Our local British car club was an international too, meeting each month alternately in Detroit or Windsor and going to various events together in one or other country. That stopped after the 2019 COVID shutdown, and it wasn't until 2022, after registering on a Canadian government app, my wife and I were able to cross and meet at a restaurant with our Canadian friends. When I arrived at the restaurant, I couldn't see any cars I recognised, and parked in a space close to the front door. As I was turning off the ignition, I heard someone holler, "We're over here," and seeing a group of British cars in the side parking lot, I attempted to restart the car. I think even before the engine, and probably more importantly the alternator, had stopped turning, whereupon the car went completely dead. Needless to say, I didn't get to enjoy my dinner with my friends, spending most of my time trying to get the car going. As it became dark, I became somewhat desperate. Getting a flatbed truck to come or go either way across the border, bridge or tunnel in normal times is almost impossible, let alone during COVID with all its travel restrictions. Our friends were kind enough to offer us a bed for the night, but the car top was down, the locks didn't work, and safe as Canada generally is, I was reluctant to leave the car in that condition, not by the way that anyone could have stolen it. With everything seeming dead, I used what few tools I had to check the battery. To do that, I used a circuit tester, but that needs so little power, even a nearly dead battery would light it. I also had a multimeter, and that told me the battery's voltage was around 12.6 volts, indicating it was good and charged. I also suspected a lock-up of one of the car's computers, the body processor module perhaps, or the engine control module. Having a small set of open-ended wrenches, including a 10mm, I removed the ground strap from the battery and then left the vehicle for about 20 minutes while I went and ate my meal. My hope here was, just as I do with any computerized item in my home like my phone, PC or router, that power cycling the car's electrical system might reset it and all would be fine again. Unfortunately, that didn't work, and then I started to use my circuit tester to go around all the fuse boxes to test every fuse. With no power at all, with the ignition switch on, I started with the fuses under hood, then went to the trunk, and finally to those at the ends of the dash. Murphy's Law prevailed, and it was in the last box on the driver's side on my left-hand drive car I found a 5-amp fuse open. Looking it up in the manual, I saw it protected the instrument cluster, which is actually more than its name implies. It too is a computer. You can see here that the cluster is directly connected to a lot of different systems in the car, and furthermore to a data bus that intercommunicates with a whole slew of other computer modules in the vehicle. I had a few spare fuses, so changed the open 5-amp, but as soon as the ignition was switched on, it too failed immediately. I believe I had no more than 3 or 4 5-amp fuses and soon blew them all. I hesitated to put in a bigger fuse, but getting desperate, I tried a 10 amp. I tentatively switched on the ignition and success. The car dash lit up, but after about 5 seconds that fuse blew too and the car was dead once again. I tried a second 10 amp fuse, but this time immediately turned the key all the way and the car started. Then that 10 amp fuse failed, as was evident from the dash lights going out, but the car kept running and at least I was able to get home in the dark with some lights. The only problem being that I had no idea what speed I was going, and much to the annoyance of the custom guy, I couldn't roll down my window to hand in my passport. The very next morning, of course, I did some investigating. I also ordered 50 5-amp ATO fuses from Amazon for about $5.99 with next day delivery, so that I could change them as they blew while I investigated the problem. That, by the way, proved to be a bad decision, those fuses being way out of specification, as I describe in my video on the subject of automotive fuses. Having already established that the fuse that kept blowing controlled the main instrument cluster, I removed that. If you've never done this before, here's a very brief description of the process. First, insert the ignition key and move the steering wheel out and up. Leave the key in, otherwise it'll go back to its original position. Next, unscrew and remove the knee bolster screws found on its bottom corners. They're 8mm hex. Then pull the top of the bolster forward slightly to detach it. Before removing the bolster altogether, release the connectors for the relay switch and the air temperature sensor. Then remove the bolster. Remove the screws from the left and right bottom of the main instrument cluster wood trim. These are number 2 size Phillips or posi drive. Now move the steering wheel all the way down and out, again leaving the key in. Remove the ground cable from the battery negative terminal. That's the rearmost battery terminal with the braided wire, and it requires a 10mm across flats wrench. Leave the trunk open or ajar so as not to require the key to open it on reassembly. Pull the wood trim around the main instrument cluster out and down to partially remove it. Then disconnect the connector to the trip computer button switch. You have to remember when reinstalling the instrument cluster to make sure that the connector to the trip computer button switch is pulled out of the appropriate top corner, depending on left or right hand drive, so it can be later reconnected. Then remove the wood trim around the instrument cluster altogether. Pull out the triangular air vent nearest the driver's door to remove it and give better access to the upper instrument cluster retention bolt nearest to it. Remove the bolts from the 4 corners of the instrument cluster. They're 7mm hex. A small telescopic magnet helps with both the removal and reinstallation of the most recessed top corner bolt. Then release and lift the levers on both the yellow and black connectors at the bottom of the instrument cluster up and fully over to jack them out to the point where they can be removed easily with the fingers. Pull the instrument cluster out top end first and remove it up and over the steering wheel. Once on the bench, the instrument cluster back was taken off by removing the 6 retaining screws shown here. With the circuit board traces exposed, it was immediately obvious that I had a serious problem. There was a fried trace on the board. Here's a close-up of the damage. A small section of printed circuit board trace is fried, and it was hard to tell if it had shorted over to either or both of the adjacent traces. These are really thin traces, and the separation between them is even smaller. There's a TO220 format transistor at the top left that I knew to have contacts spaced at 0.1 inch apart. Knowing that and measuring the number of pixels in this photo between its contacts, I could make a fairly good estimate of the thickness of the traces and their separation by measuring their pixel width too and comparing them to the transistor spacing. The gap between traces proved to be only 0.005 of an inch, while the damaged trace in this section was only 0.20 wide. Repairing this was going to be tough. Under a magnifying lens, my soldering iron tip looked the size of a submarine. This is my kludge of a repair of the damaged trace. After running a blade between the traces to isolate one from another, I soldered a jumper wire between the nearest solder pads and then put a blob of epoxy glue on the wire in order to stabilize it and to stop it shorting to anything nearby. I reinstalled the instrument cluster, touched wood, crossed my fingers and turned the key. The fuse didn't blow, but sadly nothing worked. I'm afraid I didn't take pictures of the top side of the board, but there are several integrated circuits, more numerous and with more contacts than this seat module which I once repaired. These are very easy to blow up, unavailable and not practically replaceable even if they were. I decided instead to try to get another instrument cluster from eBay. I found this one that claimed to be suitable for a 2004 car just like mine. However, when I installed it, the display panel went haywire and the message center displayed a series of errors concerning things I suppose it couldn't find and other things it could but didn't think it should. This was due to the clusters being programmed at the factory to the original equipment fit. For example, my car doesn't have active suspension, but the car the cluster came from must have had. That car evidently also had about 3 times the mileage of my car, and that, being stored in the module, displayed 2. I called the service departments of the 2 Jaguar dealerships in my area, which both confirmed that the cluster had to be programmed, but neither still had the equipment to do it, with a car which at that time was 18 years old. They also advised that the same would be true of any dealership in the USA, all of which at that time were struggling and becoming the minority part of Range Rover dealerships. My thought was, once again, that my beloved XK8's next journey was to the wrecking yard. However, if you can find other used clusters from a supplier allowing returns at zero or minimal cost, it might be worth buying them, fitting them, and just hoping that you get one that works on your car. You never know, you may even get one with a lower mileage stored in it. I think this is what I would have done were I not eventually able to fix the problem myself. With little hope of effecting a repair, I nevertheless started probing around the components close to the burned out trace. In doing so, I found that the TO220 had a base to emitter short circuit. I removed it and found it had no marking at all, so working in the dark, I tried a random and very common TO220 transistor called a TIP 41 that I already had. That didn't help, and indeed it burned out immediately. Taking more care, I traced the circuit as best I could. That isn't easy because this is a multi-layer board. That's to say that in addition to the traces or tracks you can see on the top and bottom of it, there are multiple other tracks that can't be seen sandwiched in between. Eventually I came up with a circuit shown here. This established the important fact that the transistor was of a type called a PNP bipolar, which narrowed down my search for a replacement. In my efforts to try different TO220 PNP transistors, I unfortunately damaged the trace from the emitter beyond repair and had to put the jumper wire you can see here in its place. However, the really good news is that after changing the transistor and replacing the cluster, the car worked again, the dash lamps remaining the only issue. It looked like the car wasn't a goner after all. For anyone needing to change this transistor in the future, here's a list of those I tried. The problem is, if I remember correctly, that most did not have enough gain, and the TIP 147, which is called a Darlington type, has 2 transistors in cascade configuration and has too much gain. The 2N6491 was the Goldilocks device in terms of gain, and had a good high voltage characteristic that might shrug off any future voltage spikes. Again, and this is just for reference, here's the first 2 pages of the On Semi brand datasheet for the 2N6491 transistor. Yet again, another reference picture. I bought my 2N6491 on eBay. I had to buy 5, although of course I only needed 1. At the beginning of this video I went into some perhaps tedious details of the circumstances when my XK8 died on me. Why would a car that was running perfectly suddenly fail? If you remember, I switched the car off, but as I did so heard someone call me over to park with all the other British cars. As a result, I think I restarted the car before the engine and probably more importantly, the alternator stopped turning. Did this cause a voltage spike? If it weren't a voltage spike, I had to consider what else it might be, and two things came to mind. One, dendrite growth, which I'll explain in more detail, and the other, a short circuit of an LED dash lamp, which again I'll cover later. When electronics started to be widely used in cars, makers of automotive electronic equipment were soon required to meet an international standard called ISO 16750. This detailed certain requirements, the main three being reverse voltage withstand. Should a battery be hooked up the wrong way, that should not result in any damage to the equipment. A simple diode, a one-way street to electricity, that can achieve that, and in my instrument cluster there was one right by the power input connector. Over voltage withstand. Heavy trucks in North America and some other territories run on 24 volts, and wrecking crews have equipment to jump-start these trucks with 24 volts. They sometimes accidentally apply it to 12-volt vehicles, and so the equipment must be able to suffer that for a specified time without damage. It's also probable that wrecking crews use 24 volts on stubborn 12-volt vehicles just to give them a real jump. Load dump. A battery is physically and electrically a large mass that loads the alternator and clamps its voltage down. If the battery becomes disconnected, the surprised alternator spikes up in voltage, and for a fraction of a second, until the alternator's internal regulator can suppress it, that voltage of some 90 volts must be withstood for its duration by any electronic equipment in the car. Load dump is suppressed using a device called an MOV, which typically looks like the device at bottom left and is connected right across the power input as per bottom right. The shape, duration and magnitude of the unsuppressed spike is shown at the top left, and the effect of a 30 volt MOV in clamping down that voltage at the top right. MOVs clamp the voltage down, and 35 volt MOVs or thereabouts are used so that they have enough headroom not to try to clamp the 24 volt double voltage start over voltage, which is of a much longer duration than that an MOV could withstand for long without burning out. I can't think how my alternator, that was firmly connected to the battery, could have produced a load dump spike, but perhaps there is some phenomenon that can occur if it's still freewheeling after ignition switch off and immediate switch on again. I'm no chemist, but in my career I have seen the effects of dendrite growth, and they can be very similar to the damage to my instrument cluster circuit board. The case I'm most familiar with was when an American company insisted that their Chinese circuit board assembly plant did not use polluting solvents to clean off the acidic flux residue left on the boards after soldering. Instead, they required water-soluble flux to be used and the boards be washed in slightly soapy water solution. The Chinese company followed the instruction, but once in service, the boards started to fail because of dendrite growth. Investigation showed that the Chinese subcontractor had used polluted water directly from a nearby river and so contaminated the boards. Could Valeo, that's the French company that made the instrument clusters in our XK8s, have similarly or otherwise had some polluting residue on the circuit boards? It's a possibility. Why would this happen at the time it did? Dendrite growth could be very fast, and I wonder if, because this happened on a typical Midwestern hot and humid summer evening, the air conditioning would have been on, even with the top down, and with the cold ducts running to the windshield being directly behind the instrument cluster, could condensation have formed on the circuit board, extending any dendrites, finally bridging the 5/1000ths of an inch gap between the traces. One of the things I had to consider and address here was, since the driver transistor for the dimming circuit for the panel lamps had failed, could that be due to the fact that I had swapped the incandescent lamps out for LEDs and one had failed? That concern was greatest because in a different video I had not only shown how to swap out the incandescent lamps for LEDs, I had positively encouraged it for the reason that they made the dash much more visible in bright light. Had I inadvertently exposed others to the horrible failure I had experienced? Although I felt I should address the possibility here, should others consider it too, I'm 100% sure that this was neither the cause of the failure of my car, nor could it be. Firstly, once I got the system running, all LEDs were operating normally. Indeed, thousands of miles later, they continue to do so. Secondly, should an LED fail short circuit, with the result somewhat like that shown in red here, then the discrete limiting resistor that's in series with all 12 LEDs would limit the short circuit current to a mere 100 milliamps at most, way below the carry current capability of any 220 power transistor, causing no risk to it at all. So what did cause the board to fail? I'll never know, but my money's on dendrites. My second in-line culprit was a spike from a failing MOV. That's relevant because the devices in the surge protectors that protect your TV, computer, router, etc. from line voltage spikes and surges is the same as on this circuit board, namely MOVs. Your car may not experience the number of surges that your power company are kind enough to send you, but the protecting MOV is nevertheless the same and has a finite life. Since I had the board accessible, I swapped out the MOV for a new one as a precaution. This is typical of an MOV you might find on eBay. The price, by the way, is outrageous. These things are costing fractions of a penny to make. The part number varies a little from manufacturer to manufacturer, but the format is much the same. This one has the number S14K320. This is a 14mm diameter MOV, much the same as the original on the Valeo circuit board. The bigger the diameter, the more energy it can absorb, and so the more robust it is. Too big a diameter and it may not physically fit on the board. The 320 in the part number gives the clamping voltage. This one is 32 and 0, meaning no trailing 0, so just 32 volts. 321 incidentally would mean 32 and 10, i.e. 320 volts, but that would be unsuitable for this application. If you watch this video because you had a similar failure to that I experienced, then my condolences, and I hope this video helps you solve the problem. If you didn't have the failure and watched it all the way through, then you've got to be crazy.